We're going to take the time today to sort of give you a quick outlook of how seals work, what makes them tick, and we'll go through some of the general guidelines. We'll also go through some of the more specifics. And before we start, well, I'll introduce myself. My name is Robert Weber, and I've been in this business for too long. I should have done something else in my life, but life is okay, I guess. And what we're going to try to do also, we're not going to try to change the world, because for most cases, people who buy the seals that we sell are buying replacement parts. So they're just buying, you know, they looked what was there before and they replace with what you can get in the marketplace. What we're trying to give you here, that a lot of people call in and complain because, oh, my seals don't last, or can I get something better? And what's better? Better than what? What's better than a maple glazed donut? Well, it depends what taste you like. What's better than a brown seal? A black seal? We don't know. So we'll take a look at that stuff. And we're not here to change your habits. There's going to be some slides that are going to show some manufacturers' trade names on there. Everybody knows the Sealing Solutions Group for years. Have been big Parker Seal and Freudenberg distributors, but we're not here to promote their brand necessarily. We're trying to keep a pretty objective look at different brands. What you'll find out with this, what we're also trying to prove, is that there's probably nothing like a bad seal. There's more a bad application of a seal. Every seal has its features and benefits, and it's what we're trying to give you is the tools to be able to look at if you've made the right decision. So without further ado, let's get going. And you'll see me move a lot because, you know, you got to hit that enter button. So, you know, I'm going to do a little song and dance for you. So, so this is it, Hydraulic Seal Seminar, and we're going to look at the fundamentals of all those different seals. And what is a seal? So we need to start with the definition, and people say, well, we know what a seal is, I suppose, but nice to get a precise definition. So, device used to stop the flow of any media, gas, liquid, solid, between two surfaces. You'll say, well, you know, you say the flow, we often call it liquids, but we say gas, liquid, or solid. If you're dealing with pneumatics or hydraulics, they're called fluid power. We're in the fluid power business. Why solid? Well, you know, not everything's clean, so you'll often get seals that have to stop the flow of dust, the flow of dirt, the flow of contaminants. So we take a look at that too. Between two surfaces, you'll find seals everywhere in the industry. Actually, every business that uses a seal has to look at the same parameters, whether well, I was going to say whether the missus at home. I suppose nowadays you have to be more objective. The person doing the cooking at home is a pressure cooker. You'll find that there's a gasket. So what's important about the gasket? Well, it's got parameters that you need to look at. Is it clean grade? Does it hold up steam, etc.? But it's a piece that keeps the steam from coming out of your pressure cooker. Here, from where I am here, I'm looking outside a window. They're double glazed window panes, but between the two glazings, you get a rubber seal. So it's again a seal that's used to stop the flow of any media. In this case, we're looking at a few things. A double glazed window, you're looking at gas. Your hot air in the summer and your cold air in the winter has to be sealed. The liquid when it rains, and hopefully here we're filming out of beautiful downtown Ville-Saint-Laurent, Quebec. We don't get too many dust storms out here, but if we did get dust storms, it'd be nice to keep the sand out. But so that's what a seal really is. And we have a whole bunch of seals that are available out here for the hydraulics industry. And we start with guiding elements, these rings that are often made out of glass-filled nylon, or they're made out of polyester resin, or some are made out of PTFE. We'll talk PTFE today as to not call it Teflon, but you know. And you'll say, well, that's just a guiding ring, it's not a seal. Well, they seal to a certain amount because these edges here often trap contaminants, so they're used. But anyways, I digress. Gasket products, We have, you know, you got turquoise ones and blue ones and white ones, and you know, got a vegetable fiber out of anything. And that's basically the most standard seal that's used in the industry today, is just a punch gasket, just like you make Christmas shortbread cookies, you know, the cookie cutter, not too complicated. Hydraulic pneumatic seals, you know, colors and sizes and shapes of all kinds here. What goes for piston seals and rod seals inside a cylinder. Sealants and adhesives. People say, oh yeah, but those are just chemical products. Well, oftentimes they're thread sealers or your pipe sealant. They're all keeping fluid out of threads so they don't go right through. So that's a version thereof. O-rings and backups. Yeah, so O-rings and backups, we got them in, you know, if you like colors, you got purples and browns and reds and mostly black and round. Okay, they're kind of the backbone of the hydraulics industry. You'll find them everywhere. Mechanical packing, which in the hydraulics industry, if you got some really, really old snowplow equipment, you might still find this kind of braided packing or mechanical packing in cylinder glands. But if you find those in the industry, they're really, really old. But that's fine. They still work. Rotary shaft seals that you'll find on hydraulic pumps, that you'll find on hydraulic actuators. You know, these kind of metal cased seals that have a rubber lip inside. And rotary shaft seals, people commonly call them just oil seals, but they're, some of the parameters for the seal selection are the same as we'll find in hydraulic seals, even though their dynamics of their use is different, but we see them anyways. And seal kits. So there are a lot of seal kits, which is nothing great. It's just basically repackaging individual seals to come out to the marketplace with something where it's bagged and it's ready to go. So there we go. So here we got the cutaway of a seal, of a cylinder, and we'll be looking at different places. You've got your piston here with your seals and your rod end with your seals, but you also have a lot of areas, you know, you've got the rod scraper end, you've got your static O-rings, you've got your guide rings, and that's basically what we're going to be talking about in the next little while. What you'll have to, we'll start with the general all seals, and then we'll move on from the static to the dynamic. Take a look at that. So there you go. Isn't that a pretty picture? I like it. And what we'll look at here, we have a chart that gives you different sealing parameters with, you know, your pressures and temperatures and contamination, whether it's hydraulic, pneumatic. Anyways, that's a big chart. We're not going to waste any time on that, but it's nice to know what the parameters are. We'll look at that right now. So, seal selection. How do we start a discussion on seal selection? I compare our seal selection parameters to the visit at your local emergency ward of the hospital. I don't know, people might not like my comparison here, but when you walk into the hospital at the emergency, they pass you through triage, find out what you got, and they'll ask a few questions. So they'll certainly ask you temperature, so they'll pull out their radar gun and they'll test your temperature to see if you're running a fever. Seems to be popular in these last 2 years that everybody wants to know what your fever is. It's a symptom for that mysterious disease that we can't solve. Not in Quebec, because we're still wearing masks, and we're May 10th, sorry, what am I talking about? We're still wearing masks. Okay, temperature. Pressure, so when you go to the emergency ward, they'll wrap that that inner tube, and they'll pump you up, and they'll check if you're running high pressure, low pressure. Well, I need to know hydraulics wise, what's my pressure range, just like I need to know what my temperature range is. Fluid, what are we running in our hydraulics? Are we running a water-based fluid? Are we running a petroleum oil? Are we running a polyol ester? If you're going to the hospital, they'll sell fluid. Are you allergic to anything? Are you allergic to penicillin, example? And if so, it'll give you something else. And it's important for us to find, because we have seal material that are highly allergic to certain fluids, so it's nice to know just at the hospital what you're going to break out in hives with. We have seals that'll break out in hives if you're not putting them in the right fluid. And the most important, if you go to the hospital, one of the things that, sir, what's wrong with you? What are you suffering from? You know, I need to know that too. If we're going to try to start our seal selection process, what's your application? You know, what are you trying to do? You know, do you need something low pressure? Do you need something high pressure? Do you need something that's going to last 30 years? Something that's going to last 5 minutes? Something that's going to be easy to replace, or something that's, once you got it in place, it takes you 3 days to take it apart? So they're all the things that we need to know to start. And I compare that to my hospital visit, because you got to start with something. And these 4 points, I'll be a real pain in the butt probably for the next hour or so, because I'll often come back to this and refer to this little chart. And over the years, I've always tried to drill our staff here to ask those questions, and people say, yeah, but you make us ask those questions all the time. But they're important, and that's why they pass you quickly through triage at the hospital. Here in Quebec, it's very simple. Triage takes 10 minutes, the rest takes days. So, you know, but at least when you go through triage and you get the important, you know, what are you suffering from? If you walk into triage and you take your temperature and you're running 40.1 C, they'll probably take care of you real fast, okay? Or if your pressure is at 0, or if you have a pressure leak, like blood pouring out all over, they might take you fast too. So if you're going to go through triage, make sure you're really injured. It helps, it goes faster. But that's for the seal selection. And just, well, I've got a few examples we'll look at, and I might have to ask our wonderful assistants here to cut the filming, because I'm going to need to take my plastic forks out to pull out some seals, but bear with me. All right, moving right along. Information for best result in seal selection. Okay, temperature. So we need to know what are your upper and lower limits, okay? We often have a tendency to refer to temperature as a heat problem. Well, it is a heat problem in many cases, but because we happen to live in Canada, well, some of you will say that you really don't care about the heat. You don't really care about the nice weather in the summer, but you really do care about that awful winter weather when it's like 40 below with the wind blowing. If you're watching this and you're in Manitoba, well, you'll all know Winnipeg, Portage, and Main. You want to stand in Portage and Main on a windy day in February, you need to know your lower limit. Why cycling speed? What does cycling of a cylinder do? It's going back and forth. The faster you go, the more friction you develop. And as you add friction, you're adding heat. But we'll discuss that later too. The pressure, is your pressure basically continuous, or is it one of these things like a jackhammer where you're always running on spikes and the spikes can kind of throw you off? You know, remember the last molar they fixed in the back, you know, when you get a pressure spike? Well, the system sees that too. Fluid, full immersion. So are you using a seal that's going to sit all day in that fluid? Are you going to get a little bit of splashing? You get a little bit of vapor that's accidental during usage. And, you know, if you're cleaning or installing with some pretty aggressive fluids like Varsol's paint thinners, ketone-based stuff, are you cleaning it well before you put your parts back together? So, you know, you have to take the fluid also pretty seriously. I had a friend who had that example in it, and I think it works for this too. You know, he says, "Look, I got a glass full of pure water," and then he takes out a can of drain unclogger. We'll call it Drano for those of you who know brand names. And he takes just a tiny little end of the spoon and mixes it in. And he asks everybody, well, would you be willing to drink this? And everybody says, heck no. Well, that's the same thing sometimes. Splashing vapor, it could get very aggressive and you don't want that. So you need to take that into consideration. Moving right along. This one's application. What are you doing with it? And it's mostly, what is your expectancy of your seal performance? You need to last a long time, or are you in our business, you like selling replacement parts, so you hope they'll just last 90 days and then you can sell some new ones, you know? I mean, that's your business, not ours. So this is some speed. You need certifications. Are you dealing with armed forces? Are you dealing in the food industry? Are you dealing in places where you need to come with certain kind of certifications? You know? Choice of profiles, alternatives that are based on experience. Oftentimes, you'll look in a book and it won't tell you exactly how it goes, so you have to base your choices on something that's worked before. And that's also, there's nothing like having good past history to help you select. I was mentioning before that here is what we discussed. We are going to show you a graph that's published by Parker about packing compound heat ratings. We're not here to promote a brand. We're just using their literature to show what's out there. And I'm sure most seal manufacturers in their handbooks or on the web or wherever you're going to, or if you call them up, they can give you exactly the same information as we're going to see. And it gives you typical pressure ratings for at 70 degrees C. We use that 70 degrees C because it's a good average temperature that takes in consideration, you know, expansion, softness, etc. All we're trying to prove here is that depending, you know, what you're using for pressure ratings, 70, 80, 90 shore area hardnesses, well, the harder the material, the higher up you can go in pressure. So all we're trying to tell you, depending on what material you're using, you're going to be able to hold higher pressures, which is not a be-all end-all, but that's part of the equation. Okay? Recommend temperature for Parker packing, and again, we use that because I love this graph, beautiful colors. That graph's going to be at least 40 years old, but that's fine. It's like good art, it's timeless. Yeah, but then again, it'll show you the range from, you know, what goes up to, let's say, in and around the colder winter temperatures, and then the higher, and as you see in the high end, there's a lot of variety in what you can get. So it's always important to get the right information from your customer, and these are shown as examples only, and we'll discuss a little later what a compound is, because you can mix stuff and you can get compounds of the same base material that'll bring you to higher temperatures or lower temperatures depending on what you put in your cake mix, but we'll get there. And a fluid compatibility table. It is Parker because it's got all the Parker branding. But again, a fluid compatibility table, it tells you what you can use here or what you can use there. Often it's the same thing like when you're getting stuff at the drugstore, you have to check what you can use it with or what you can't use it with. So I was at the garage this morning and they have this moly-filled oil additive, and they said not to use in motorcycles that have wet clutch systems. So, you know, a lot of places will tell you where not to use it. So here you'll have a typical chart that'll tell you fluids and water glycols and aircraft type fluids and phosphate esters, where they work, where they don't work. So if you look at your charts, it's important to know that. Dynamic application. Here's another thing we'll discuss in terminology. In our industry, in the hydraulic seal industry, we like calling things, there's two big families. There's the static seals and there's the dynamic seals. Your static seals are the ones that once they're put in place, there is no more friction put upon that seal. It sits in a groove and nothing else moves. So it's kind of like your door gasket in your car. We were discussing, and I'm going to go like this to show the windows, but you can't see them. But our double pane windows, once you've got that gasket in there, nothing moves. So it's static. Dynamic application, you know, we're going to look at some things over and above statics and dynamics. We're going to look at, you know, whether you're running lip or squeeze seals, whether you've got problem areas on the dynamics and the seal contact area. So we'll really take a look at our dynamic seals a little later on. Take a look what the lip looks like, and it's kind of like choosing a tire. You go buy tires for, oh, I like this kind of wear pattern, I like this kind of tread. Seals are a little bit like that. This is important. Other criteria, we'll take a look at a few things that you need to look at depending on where you're using it. First of all, ozone resistance. What is ozone? Many years ago, in our great Save the Earth, we were worried about the ozone layer. It's not really that kind of ozone we're worried about. The ozone that is produced by the arcing on electric motors. Like if you watch closely an electric motor that's not completely enclosed and you shut the lights down, there's always a bit of sparking between your stator and your rotor. Well, that is what produces ozone. Kind of like sometimes you get that weird smell right after a thunderstorm. Well, when you get a lightning strike, it develops a whole lot of ozone. What ozone does in a plant environment is when you're putting parts close to electric motors, ozone can prematurely crack the surface of your seals, and something that's left, example, if you leave all your O-rings hanging on a nail in the compressor room, you might find out that they look on the surface, they're all chewed up. It's the ozone attack. Easy way for that. Keep them in plastic bags, but we'll get there. Shelf life. Here's something interesting. Seals, after a while, they will, if they're left in the open air, they'll kind of lose their, kind of like that piece of bread you left on the counter last night and you forgot to wrap it up. It's kind of stale the next day. Seals can become stale over time if they're not properly protected. And there's a lot of people will, for shelf life, they'll say, oh, I'll buy 20 pieces, I'll have them for the rest of my life, okay? Well, if you only need one per year, in 20 years, will they still be as fresh? Did you need to buy that many? Or if you do want to buy that many because you got a volume rebate deal that you couldn't pass up, well, then you have to make sure that you protect your parts well on the shelf. So shelf life is important. And if you're dealing with certain industries like renewable energy, like military, they'll often ask you the shelf life. They want to be assured that you're not sending in something that was produced 25 years ago and you're just trying to get rid of. So shelf life. Abrasion resistance. Not all seals work very well in surface where there's abrasion, whether it be by contaminants, whether it be by surface finish. Our industry, which is hydraulics and pneumatics, uses a fair amount of polyurethane material. And why polyurethane? It's not the greatest seal material for bounce and rebound and memory, but polyurethane is a tough material. That's why you'll see polyurethane wheels on roller skates, you'll see them on skateboards, you'll see polyurethane based floor paint, you'll see rollers and casters. And that's why our industry uses it, because there's a lot of abrasion when there's a dynamic interface. Compression set. This is kind of my weakness here. This is my box of chocolates that I like to dig into. I'm going to be a real pain in the butt here on compression set, because I think it's one of the most revealing specifications of a material. What is compression set? And I had a training last week in one of the local colleges. You have a nice living room but your overweight Uncle Ernie. I hope none of you listening to this have a overweight Uncle Ernie. I didn't mean to pinpoint him, but anyways, and he always sits in his armchair. And if you look at the cushion, because Uncle Ernie is a couch potato and he never gets up, if the day he does get up, you look at the cushion is probably all bent out of shape. You know, you can, well, I won't get into details of what the shape of the cushion's like. Rubbers and urethanes, same thing. A compression set, if it keeps compressed all the time, you want to know if that material has the capacity to bounce back to its original shape. And the lower the compression set, because the compression set is a value that we'll find in our books, it's a percentage on how much the material did not come back to its original shape. So if you have 70, if your compression set numbers are 70, that means there's 70% of the squeeze you put on that material never came back. So the lower the number, the better it is. And people never really spend a lot of time buying parts based on compression set. But if you're looking at an application where your O-rings, we've got O-rings that we supplied in the early 80s. Sorry, I was there. Yes, I know I'm old. That's why I'm retired. But they're still in service. You know, they chose a good compound, lasts a long time. You've got people, example, in the hydroelectrics with those turbine seals that are, you know, you need a 200-ton crane to pull the parts out. So they want something that lasts a long time. You got to check your compression set numbers, and then again, they're available. I mean, any material that we sell here, we can give you the compression set numbers, which are based on an ASTM specification. So compression set, it'll give you a long-lasting seal that will continually recover from its original deflection. Friction requirements. If you're running pneumatics, you want low friction because you don't have a whole lot of pressure. If you're running parts that have a lot of stroking in a day, you want low friction. But if you're using parts where you really need something to hold in place, example, a cylinder that will be holding, let's say, a cherry picker or a boom extension that stays stationary for a long time, you like that seal to have high friction, good gripping. So again, it's a question of application. Remember, I told you I'd probably be a pain in the butt because we'll go back to that first line. You know, what's your pressure, what's your temperature, what's your fluid, and what's your application? You need to know that. So, friction requirements. Seal life. Seal life's important too. Like if you have an application where your seal selection is fine, everybody loves it, and anyways, once a year during the summer holidays, the maintenance crew comes in and tears all the seals out and put new ones. And if it worked first, maybe you don't care too much about seal life. If every time you change a seal, you have to stop the machine for a week to change a $2 seal, then seal life becomes important. So again, application, what's the application? Seal life. So we're talking fluids. Remember, like we said, you're going to check if your fluids are compatible. I did a little test, and when we left, I said I was going to take my plastic forks and get. So what we did, took a couple of O-rings. This was, sorry, I'm getting out of the range. We have a EPDM O-ring here, which is purple for identification purposes, and we have a brown fluorocarbon one with the same size. And I think I put them in at about 9:15 this morning in a polar solvent, which is called MEK or methyl ethyl ketone, which you'll find often in paint shops. And so it's not a petroleum base, it's not an aromatic, it's really a polar solvent like acetone and ketones. Yes, what time is it? 10:20, so it's been in for about an hour in the fluid. I just pulled them out, so I hope the camera will be able to. I'm gonna try. I don't know what's the best way, but I got a mini monitor here, but oh, whatever. You'll have to trust me if you can't see it. But remember, I had these two same size, and after an hour, the purple one, the EPDM, it holds up. But the fluorocarbon one, it's like 50% bigger, both in cross section and diameter. So it's not compatible. And like I said, it hasn't been in the solution for 2 years. It's been there for 1 hour, and you see the difference. So all we're trying to do with this one is to say it's important, because if you use something different, a good friend of mine just had her wisdom teeth pulled out, and he gave her antibiotics, and 12 hours later she broke out in hives. She looked like a permanent attack of chicken pox or measles or whatever. Certainly that didn't work with her. So same thing with her seals. And I just wanted to show you that as a little sidebar here, but we'll look at some of our common fluids. And in the hydraulics industry, we're still running, I would say 90% of our applications that we see on a daily basis are mineral-based fluids. So it's your standard yellows and red hydraulic oils, your transmission oils, Dexrons, etc. Most people are still running that. And usually what repair shops and most manufacturers of cylinders will stock are everything that runs well in mineral-based fluids. So that's fine. Where it gets tricky is in certain applications where the mineral-based oils aren't compatible with the application of the cylinder, then you end up getting my favorite, synthetic fluids. What's a synthetic fluid? Unless you're using, first pressed extra virgin olive oil, which that is a pure vegetable oil or canola oil. I mean, most fluids that we get today, they are synthetic. They're processed by a synthesis of reaction between chemicals. So that's why I say be precise. I say I use synthetic oil. Can we be precise? If I need to know where you come from, you say, oh, I'm a human being. Yeah, I know, we're surrounded by human beings. Can we be a little bit more precise? So what kind of human being? Are you male or female? Do you come from this country? Anyway, so synthetic fluids, that's not a good answer. If I ask you, what oil are you using? Oh, it's synthetic. I say, wait a minute. I'll ask you a few more questions. So, high water-based fluids, that means you got a high percentage of water in the mix, and sometimes you'll get anti-foaming agents, you'll get anti-corrosive agents. Everybody says, well, why are you worried about high water? The problem with water that we'll see in our industry, and a lot of products don't like water when you're taking it, let's say over 80 degrees C, and then hot water starts breaking down materials, and you think, yeah, but I wake up every morning and I take a hot shower. I'll tell you what, if you're taking a hot shower at 180 degrees C, you'll break down too. So you got to watch when we say high water. There are seals that you cannot use, and one of the big seal material, popular materials that we use in the industry, which are polyurethanes. Polyurethanes don't like water at really high temperatures. You get hydrolysis, they fall apart. So we need to know. Phosphate esters were the fluid of choice if we go back 30, 40, 50 years ago. If you were working anywhere where the temperatures were high, whether you were in a foundry or in a smelting plant, and that was the fluid to use because it couldn't catch fire. Problem with phosphate esters, they were really hard on the environment. They were hard to get rid of, and so you don't see all that much phosphate esters. Mind you, if you're doing any work on aircraft, aircraft landing gear, use Skydrol, and Skydrol is a phosphate ester. So if ever you're repairing strut cylinders on a plane, you might want to check what kind of fluid they're using. Kind of interesting when you're trying to land the thing and the landing gear doesn't come out because put the wrong seals in it. But anyways, polyol esters are sort of what replaces phosphate esters. Polyol esters, you sometimes have to watch the elastomer you're using. A lot of the polyurethanes, PTFEs, nylons, all that are fully compatible. So again, it's ask questions when we're not sure, and that's why most manufacturers will post their fluid compatibility tables, whether on the web or whether in their catalogs. I'm kind of a semi-dinosaur here. I still trust my old catalogs, a printed version. They're handier to read in the bathroom than using a laptop and whatever. How did we get into this? Blends. I use blends as an example because in the trucking industry, you'll find that often what's in the oil tank is a blend. It's a blend of every time they were missing some kind of oil in there, they fill it up with whatever they have on the shelf, and all of a sudden you get this kind of weird soup. So blends, if you have a problem with seals don't last because you think it's the fluid, and it kind of, you're trying to ask questions from the user and it's kind of vague, good to get an oil analysis from a lot of the repair shops are equipped to be able to do that for you. So those are common fluids. These are really common because everybody mixes up stuff, but that's the... there's one thing I forgot, and remember we talked about temperature, and I'm just looking at my little box of samples. We talked about temperature, and I've always liked this kind of thing, trying to emulate, a tuna melt. This is a seal melt. They're all polyurethane materials that were put in an oven. I do believe that in and around 200 degrees C for I don't know how long. But they put different seals from, I gather they're all from the same manufacturer, at least 4 of them are. So, so you can't say, well, yeah, Parker rigged the test because they are Parker parts. But like you see, some will handle heat a lot better than others. And it doesn't mean that one's better than the other. One's better than the other at temperature, but maybe that's not, maybe you don't need high temperature, maybe you need low temperature. I'm just saying, so temperature is important because you don't want a cheese melt, and fluid is important because you don't want swollen seals. So we move on. Sealing fundamentals. The key to success. A resilient seal equals conformability. What does that mean? That means when you're going to, since most of us are Canadians that are listening to this, when you're going to your local gas station to fill up in the wintertime, and there's been a lot of salt or dirt on the road, and you're cleaning off your windshield with the squeegee, and you get those squeegees that the rubber's old and the temperature is really low, and you try to clean the window with the squeegee, but it's hard as a rock, so you're not cleaning anything. Well, that's because you're not getting any more conformability. The rubber's getting hard because it's old, or the temperature's too cold for it to work. A seal to work well, it's got to be able to conform, and that's why most seals, are made out of materials that are resilient, that bounce back, that are soft enough that if they're going over the peaks and valleys of a surface finish on a cylinder, etc., they will conform to the surfaces you're putting it to. So you want them to conform, and that's why you buy resilient seals. I mean, we got cast iron seals. There's an application for those, but cast iron seals, they're not resilient and they don't conform. Is that a bad seal? We'll discuss that on another day, but that's the number one thing to remember. A good seal will be able to conform. That's what can give you good wiping ability, good rebound when you got pressure cycles, very important. Okay. And sealing fundamentals, static sealing, we discussed that before, versus dynamic. What's the difference? Remember that first slide? I said I'm going to go back to that one often, and we're talking, what are the sealing parameters to start off with? We go back to our triage question. Temperature, pressure, fluid, application. I said you're going to be sick of me by the time we're finished this one, but so a static seal and a dynamic seal, you always gonna have the questions. Remember, what do we say? Temperature, pressure, fluid, sealing ability, application. So both have that, but we got a little bit more. Okay, a dynamic seal, we're adding movement. I'm going to try to take something apart here. I hope It doesn't take me for hours. So you have here your typical cylinder here, and we're gonna try to take it apart quickly. So you have a piston here that has some seals on it, okay? And as the rod strokes, well, these piston seals rub against the inside of the canister, okay? So they're dynamic. Oh, where'd my slide go? Come on, slide, come back. Oh, no, there you go. So you get friction, okay? And the same thing on the rod end of the cylinder. You also have, in the cylinder head, you also have another seal, okay, because it's sealing the rod. So because we have great imagination, the seal that seals the rod, we decided we call it a rod seal, right? So far so good. You won't be able to see it. You have to take my word for it. But if I look in here, I got a little seal in here. And as the rod strokes through it, there's friction on that seal too, running friction. So you get friction. However, on that same cylinder, when you assemble these parts together, you get a little O-ring here so the oil doesn't pass through the threads. Well, it's not moving against another surface. It's static. And when I pull in my threads here, I have an O-ring and a backup. Once that's in it, that doesn't move anymore. So you got dynamic seals, you got static seals. Problem areas on my dynamic seals, friction. Every time I get a stroke, I'm rubbing a piece, polyurethane, rubber, PTFE, whatever, against a surface that doesn't move, so we're generating friction. When you generate friction, you generate wear, you know. That's why when you're using, whether it be a file or an emery cloth or a cutting tool on a lathe, it always removes material. If you know of a tool that adds material when it rubs, tell me, we'll patent that, we'll all get rich. But in general, wear, you're losing material. So friction and wear, not a good thing. We're looking at sealability because the friction and the wear and the movement will affect your sealability. And of course, because we're doing a hydraulic seal seminar, we're kind of interested in if we can get good sealability, okay? We'll talk about extrusion and clearance. What's extrusion? It's when your gaps are high. You know, it would be nice that this would be so tight that nothing could pass between, okay? But you have to give clearance so the parts can move. So in that clearance, you have too much pressure, the seals will start blowing out, and we'll see some slides later, okay, that will push the seal right out of its groove. And the other thing is stability. There are still some seals that have shapes that when you get movement, the seal can roll around in the groove. So those are problem areas that we have to look at. One thing, and that friction causes too. Friction causes heat, okay? And we've always noticed over the years that you can easily add 20 to 25 degrees Celsius, or about 40 degrees Fahrenheit, if you have a high friction seal. You know, we were looking at the top end temperature ranges of our seals. If you have a lot of friction on your seal, you might want to also, as a safety factor, add 40 degrees for the heat that's going to be generated through the friction. Something to think about. The other thing that we see a lot nowadays, a lot of our shops and manufacturers complain, what's the other thing that friction does? And I kind of like when you go watch a basketball game, you know, other than the unruly crowds and the bouncing of the ball, there's a lot of squeaking going on. Those are all the sneakers against a hard floor. Well, that's friction, and the extension of friction is noise. So sometimes people say, cylinder's noisy. It screeches, it squeaks, it squeals. Friction's your man. Got to take a good look at that. So, just hold on, bear with me. I'm getting old. Okay, sealability. this is a really crude chart, but it shows what we're trying to look at in sealability. And remember, if we go back, I'm going to get you going back and forth, but we have to look at these three items first, okay? These three kind of, they go together, but they go against each other. But you have to take them as a package. And I will say, remember at the beginning, I think I said we're not trying to promote a brand or anything, because at the base of everything, every seal is probably a good seal. It's how you apply it in your use. And we're going to look at those three for all of you listening out there that either, I'll just use the term married for now, okay? And I'm not trying to get into what's politically correct. If you're married and you have been for years, well, guess what? You know, I'm sure if you're still married, it's because the pros outweigh the cons. Okay, so you made a choice based on the compromise. Yes, I'm willing to live with that person. That person snores at night. I can't sleep, but other than that, he or she's a peach, so, you know, I can live with that. Well, you're going to find that here. The seal that you choose will always be a compromise somewhere. I chose that because it's the best that I can find, but there's a downside to it. So, why did I get into marriage? I have no idea, but we're moving on here. So, we were saying sealability. Watch this, okay? In our industry, we talked about static and dynamic seals. In lip shapes or in seal shapes, there's two different families, okay? There's lip seals and there's compression seals. And like I said, the drawing, it's crude, but it serves a purpose, okay? Pure lip seals, some manufacturers call their seal parachute packings. How does a parachute work? Well, if you jump out of a plane, then there's air pressure under you and catches into the parachute and it opens it up. That's why you could hopefully make a safe landing and not break both legs or more or whatever. And you have some seals that are pure compression seals, okay, which are, you take a seal and you put it in a groove and you compress the daylights out of it and you hope it'll make a seal, just jam it in there, okay. So we're looking at two different factors here, okay. Example, and then again, I'm not sure with the camera if my little sample table will give you here. This is called a piston cup, okay. It's a cup type seal, so this is the lip here and the way it works. Like if I had a little G.I. Joe statue and little 4 pieces of thread, I could hang them down here and I could drop them out of the window over there and be a parachute, right? The pressure opens up the piston cup, holds it up, okay, and I have this little rubber U-cup that has 2 lips in there that are very flexible. For these to work properly, to seal well at 0 pressure, they don't, because there's no pressure to open them up, okay? You also have, I have a piston here where I have a 2-piece seal, where I have a rubber expander in there. I don't know how well you can see it, and a ring on top. And if I look at it, the ring is bigger than the piston, at least until it's fully compressed, which I can't show you because, well, I don't know if you have an idea of my size, so I'm not a big guy, so I don't have a lot of strength. But once I get the 2 tabs together, that thing is, I've compressed the daylights out of it, then it becomes a pure compression seal. What the diff? So if I need the pressure to open the seal and I have very little pressure, what kind of sealability do I get with these type of seals? Well, these type of seals need the pressure to work, but there's no pressure. So a pure lip seal, it has poor low pressure sealing ability. Why? Because there's no pressure to open it up. The squeeze seal, you force that thing in a groove and into a housing, so it's fully compressed. So you're going to get excellent low pressure sealing ability because you jammed it in there. But remember that marriage thing about snoring at night? Okay, so low pressure sealing ability, but you get low friction because when there's no pressure, there's nothing activating the seal. So no low friction, low wear. Whereas your compression seal, excellent low pressure, but you get high friction, high wear. Which is the better seal? Here's the question. What is the better seal of the two? You would say all, or you could say none. But the best thing you could say, it depends on what? Temperature? No. Pressure? Maybe. Fluid? Doesn't. Application? Depends on your application. So remember that first slide with those 4 things there? Important. Okay? So if you're looking at a pneumatic cylinder where you're running already at little pressure, you have just enough because the material is soft, it opens fairly quickly, so you can pretty quickly catch up what you're missing on the pressure. But on an air cylinder with little friction, with little pressure, you need low friction, you need low wear. On some heavy duty cylinder, they're always pressurized. You've got enough pressure in the system to overcome the high friction and high wear, but then you can play with your materials to find a material that has better wear characteristics. So sealability, it's all based on the basic profile of your seal. Lip seal versus compression seals, which is the best? Depends. Remember the word, depends. Very important in our business. Okay? And this you got to remember. There's a lot of people think, no, high pressure is always a problem. High pressure is a problem, but it's not a sealing problem. Most sealing problems occur at low pressure. Why? Because I don't have the system's pressure to activate the seal if it's in the lip seal category. All right? So a lot of people tell, no, I need to seal. It's high pressure. That's my problem. Well, your seal is probably extruded. It's probably blown out at high pressure. Well, that's not your problem, or maybe it is your problem, but it's not a sealability problem. So you have to be careful with their words. Okay? Pressure increases conformity on seals. I didn't invent anything now. Probably Mr. Pascal, who invented what did Pascal? Well, Pascal's law about how pressure is equal in an enclosed container at 90 degrees from whatever. You know that guy? That guy. Friction factors. Okay? Unit load squeeze. So we're discussing, remember I pulled out this piston here, and we said that's high friction because you got a rubber part underneath this that keeps putting tons of pressure on that outer ring, and it's got no room to move. Okay? It's going to seal well, but it has so much squeeze in there that it has a lot of unit load, so it gives you a lot of friction. So if you want to lower your friction, you got to lower the squeeze. So maybe find a material that's a little softer, lower diameter, or maybe less material to squeeze in the groove, and go maybe to some of the other types of products that are more of the lip seal variety. Surface finish. Okay, this is the double whammy here. Everybody will say if your surface finish is poor, if your RA, your roughness is on the high end, sure, it's going to cost you a lot of friction. It's like rubbing sandpaper over something. So people say, yeah, we get it perfectly smooth, that's what we like. But if you get it perfectly smooth, if you get, remember this canister, this barrel? So we're going to get that inside, we're going to get it smooth, it's going to be like glass. And then you're going to call me in a couple of days and say, I can't live with that. It squeals all the time. Well, you have to remember that on a hydraulic cylinder, that's why we give it a range of surface finish. If it's too smooth, the little roughness that you get in a barrel, those tiny grooves, they're used for oil retention. I mean, they're not typically oil retention groove, but they have a way to getting held in that surface finish to lubricate the seal as it goes past. So if you don't have that anymore, then you're running dry, kind of like running your fingers on a pane of glass, on a window. It's okay for the first 10 seconds, but if I tell you rub your fingers against the window for an hour, you might find that you get a bit of wear or a bit of heat on your fingers. So that's why most books will give you a range of surface finish that, a lot of people use honing stones, so you get the honing stones of the right grade, sort of like when you're trying to sand a piece of paper, you might get 400 grit, or you might get 200 grit, or you get 40 grit. The same thing. Okay, material hardness. The harder the material, the more friction and heat you're going to generate. That's why we also offer a variety of hardnesses to work with. Speed. Okay. The faster your strokes are, the lower friction. Because, shouldn't that be the opposite? The problem is, as you lower your stroking speed, your seal ends up having the time of day to pick up every little bit of lubricant on the sealing wall. So it's really going up, and it's kind of like when in that wonderful, let's go back to a married life, to do a good job when you're wiping the dishes, take your time. And if you have more time to wipe the dishes, you get them really nice and dry. And if you go fast, you'll probably leave a little film of water on your dishes. Same thing with the seals. If you're going fast, if you have a lot of stroking speed, those seals kind of glide on top of that surface finish, and so you get less friction. So much for home cooking here. You heard it here first. We do a little bit of everything here. Okay, pressure. Of course, the more pressure, the more friction, because the pressure is going to push the seal out, put more force to push it up against the dynamic walls. Lubrication, that kind of goes without saying.